Hello and welcome to the 6th lesson in the first phase or the first session of our training as far as basic programming techniques is concerned. So let's quickly go ahead and look at the course outline for this particular lesson. So in this lecture, we're going to look at the loop or repetition and then the control structure, in which we have the for loop, while loop, and then the do while loop. These are the three basic types of loops we have. So we're going to look at them, how they are used and how they are written and all that. So let's look at the lesson objectives. So by the end of the lesson, learners will be able to, there's a straightforward objective here, explain the concepts of the three basic types of loops and be able to use them in writing simple programs or algorithms. Basically, that is that. So let's quickly dive right into the contents. Now let's talk about the introduction. As we've already done in our previous lesson, we've written series of programs or algorithms and all that, and we have understood the basic constructs that we've already written. So let's proceed. All computer programs are created from three basic constructs, that is sequence, decision, and then repetition. We've already spoke about sequence and then decision. In sequence, we said the programs are written in sequential, just straightforward, no curve, no bend anywhere. And I'm sure you've understood that. And then we talk of decision, where at a point in time, the program stops and makes decision. So we spoke about that as well, and we've written a lot of algorithms, pseudocode, and flowchart on all this. In here, we want to look at what? Repetition, that is looping in our programs. Now, so the ability to repeat the same actions over and over is the most basic requirement in programming. The ability for a particular program to permit you to perform a particular task over and over is one of the basic requirements of a program. The program's ability to stand something like that, it's a key to that particular program. So a loop in a computer program is an instruction that repeats until a specific condition is reached. Anytime you hear loop again, from now onwards, the word loop in programming shouldn't be something new. We should understand it and be able to explain how it is used and how it is written. So let me go over it again. Say a loop in a computer program is an instruction. A loop is an instruction that repeats until a specific or a specified condition is reached. This means that before a program will look through sequence of statements, there is a condition that is set. If the condition is met, then the program jumps out of the loop and then it terminates. So basically, that is what we are talking about. Now, each computer task being performed has been coded into the software by a programmer, and each task must have the ability to be used over and over again. For example, in using a program like let's say Mavis Beacon to learn how to type. In the process of typing, as you are typing, the program is looping and there are some conditions that are set. If the condition is met, then the program stops and then display maybe your progress on the screen and all that. So basically, that is what we are talking about. All this thing has been coded into this Mavis Beacon in a way that when you type and you get to some limits, then it stops and tell you the time, the number of minutes you typed, and the number of word per minute and all that. So in the process of typing, the program is looping and checking all these conditions. If they are met, then it stops and display this for you to see. We'll be seeing series of examples as we proceed. So loops, repetition, and iterations, they are just the same. Looping, repetition, iteration is the same thing, just repeating a particular block of code as long as the condition remains true. That is what we mean by looping, repetition, or iteration, whichever you decide to mention it, it's okay. The loop statements are code block which under certain conditions will be executed repeatedly. Like I said, before a code or block of code will be executed repeatedly, there is a certain condition. If the condition remains true, it will keep repeating until the condition turns out to be false. We'll be seeing all that. A loop structure contains a branch which results in a block of statement that can be executed many times. When it gets to that particular block and look at the condition, it will permit you to be repeating the action, and it will be looping. it will check after the first iteration or after the first looping. It will go over and check again. How is the condition? Is it true? If it is true, do it again. Then you do and check until the condition becomes false. That is until the condition turns out to be false. That is when it will jump out of the loop, skip that block, then go to the next block, which says that if the condition is false, that particular block should be executed. So it will be repeated as long as the given condition within the structure causes branch to be broken, unless this particular statement here means what? Until the condition turns out to be false. That is when you jump out of the loop. So it's as simple as it will continue to repeat until the condition remains true. Say what? Loop can execute a number of times without any user input by the use of what? A computer variable. There are some loops that can be executed a number of times without you entering anything. For example, if you start a program, it is looping. The program is looping. As long as you use the program, it is looping. There is loop going on there, and it's giving you the opportunity to repeat any action at all in the programming equation. So until you decide to click the red button here, which says what? Close, that is when you terminate it by yourself and then you close it. So the moment you start Microsoft Office Word, as you do everything, you type, you bold, you italic, you underline, you do whatever you want. The program is in a loop and it's checking all this until you decide to click on the red button, which is close the program. That is when it jump out of the loop and then it terminates. Now, what is a counter variable? A counter is a variable that is incremented or decremented each time the loop repeats. There are some loops you have number of times that you should be giving. This normally happens in games. For example, a game can give you the number of times you can do what? Maybe repeat a process, maybe play. Maybe there was a game we wrote in Scratch. It's just a normal game, just as any other game. Like maybe let's take Super Mario for instance. Those of us, or any game at all, which the moment you start a particular game, you are given some number of lives. If you play the first round and you are caught and something happened, then the life reduces. If you are caught again, then another one reduces. If you are caught again, based on the number of lives you are given, until the number of lives you are given reaches its limit, you still play the game. But if it reaches its limit, jump out of the loop and then it says game over. Now this counter variable can be set to what? Increase or decrease. That is what we are talking about here. For example, at the start of the game, I give you lives to be 3. You have 3 attempts. So in the first attempt, if you are caught, then it reduces by 1. So remaining what? 2. If you are caught again, reduces by 1, remaining what? 1. If you are caught the third time, then it tends to out to be 0. Then I'll say game over. So this type of what? Variable is what? The decremented type. It decreases any time you lose a life. There is another one which we call what? Increment. That is the incremented type. With that, I can say the number of lives or your limit is 3. And then I'll set the initial value to be what? 0. If you are caught the first time, it increased by 1. You are caught the second time, it increased by 2. You are caught the third time, then by 3. Then in that case, I'll compare it to what? The limit. If it is equal to 3, it means game is over. So in that case, I'm what? Incrementing the variable. So if it gets to its limits, it jumps out of the loop and display whatever it is on your screen for you to see if it is game over and your score level and whatever it is, and you see all that. So basically, that is what we are talking about here. Now, a loop is divided into 2 parts. We have the loop control statement and then the loop body. Now the loop control statement, this defines the number of times the loop will be executed as long as it is true. That is, once the test condition statement is true, the loop runs again. So with the loop statement, it is a statement that is executed based on the condition that is given, and that particular statement will keep executing. Say what? Loop control. So this defines the number of times. The loop control statement defines the number of times the loop will be executed. So the loop control statement here defines the number of times the loop will be executed as long as it is true. That is, once the third condition statement is true, then the loop runs over again. So let's say, let me give you a typical example here. let's say we want to prompt the user to enter a particular number, and then the number should be what? Odd. So the first thing we are going to do is this. You input the first number, then we check, is the first number odd or even? If it is even, then maybe after entering the number, if it is odd, we would like to what? Okay, we want the user to input only odd numbers, like 1, 3, 5, and all that. So in the process of entering the odd numbers, if you mistakenly enter even number, then you wouldn't be given a chance to proceed again. Good. So in the first iteration, when you put in 1, it will check. If it is odd, then you'll be prompted input another one again. So that is the work of the what? The loop control statement. It defines the number of times. Then after that, then you put the next one, which is 3. Then it checks. Oh, it's also another odd. Then enter again. Then you do that. So until all the numbers you are entering there are odd, you keep entering. But the moment it turns out to be that you've entered one which is what? Even, you jump out of it, and then that is it. So now the loop body, this holds the statement code or instruction that is executed with each loop or cycle. So the loop body will be like, anytime you enter an odd number, display it. Very good. If you enter the odd number, then you display it. So as long as the numbers you enter here remains odd, it will be displaying them. By the time you enter a number which is even, that is when it will skip this and then go to the next line of code and then do whatever it is instructed to do. We'll be seeing series of examples as we proceed. Very good. This is a typical example. So this program segment repeatedly asks the user to input a name until the user enters done. So this program, you will be entering series of names. You can put Ajua, Ama. It's like there is a secret name that we need in this particular program. Until that secret name is entered, you will be given the chance to what? Enter any name at all of your choice. So that is what the program is all about. So we declare the name we're going to enter as what is string, because it's a combination of what? Characters, as we see here. And the name we want you to enter here is what? Done. But we assume that you don't know the name, and for that matter, you are given a chance to what? Enter series of names until you enter this one. So we declare it as a string. So you are given a chance to what? Repeat. So you say what? Repeat. It means you have the chance to what? Enter any name at all until you are able to enter name which is done. So you say what? Right. Enter the name of your brother or your sister. So it could be that the name of your brother or your sister, one of them is done, it's called done. So until you input this, the program gives you the opportunity to repeat over and over again. So this is what the statement here. Now, the moment you input the first name, it will input it and check. From here, it will compare the name you've entered. Let's say you enter Kofi, then it will check, is Kofi equal to Dan? No. Then it will prompt you, enter again. Ama, is he equal to Dan? No. Enter again. Yao, is he equal to Dan? No. Until you enter a name D-O-N-E, which is Dan, then it will compare. Is Dan equal to Dan? Yes. Then it will display maybe something like, hooray, you've gotten the secret name or whatever. This is just a simple game. So basically, that is how loops work. They give you the chance to repeat an action for a number of times until the condition turns out to be false. That is when it jumps out of the loop and then display whatever you have given it to what to display. So that is that. Now let's look at what we term as infinite loops, or indefinite. We can also call them indefinite loops, right? So if a loop's test condition is never satisfied, then the loop will never be exited, and it will become an infinite loop. You know, there are some loops that we don't specify the number of times they should be executed. So if it happens like that, it will keep running and running and running and running until you decide to stop it by yourself. It will never stop. So if it happens like that, this type of loop is termed as what? An infinite loop. It's a loop, or if a loop's test condition is a loop which test condition is never satisfied. Okay, that happens like that its test condition is never satisfied. It means it has no place that until this condition is met, stop and do this. It means it will keep running until you decide to stop it. So let's look at this. Say infinite loops can wreak havoc on a program. It can cause a lot of damage to it. Although computers say what? When you set up a loop and put in a test condition, be sure that the test condition can be met. Anytime you set a loop, for us to prevent this particular issue, let's say for us to prevent the issue of having an infinite loop, make sure that the condition you set should be met. And if that condition is met, then that is when the loop will stop by itself and then display whatever output you want it to display after it's exited or whatever. So basically that is that. If it is a game, you can't tell the user to be playing the game until the user gets tired and stop, right? At least for the game to be fun and for your program to host your machine or your PC or whatever game to run successfully, there must be a point in time where you stop. So even a typical example is the football game, the PES and all that, which all have timing. So as the time is increasing or decreasing, it is looping. So there is a time that when it reaches that time, it stops and say half time. Then maybe first half is over and change to a second half. Within that process, at least the loop has stopped and then it's ready to start another action again. So basically at that moment it has rest for some time and it's ready to take another action. So basically that is that. Although computers don't mind doing a task many times, but forever is simply too many. Imagine you playing a game forever. Even if it's thousands or billion minutes you are still playing. You yourself, in fact, you wouldn't even enjoy the game. So there must be a limit for everything. Yes, sure, that is what we are talking about here. If it happens that a particular game or a program has no limits, it has no condition which says that when that condition is met, it should stop, then it becomes an infinite loop. So that is that. So let's look at example here. So declare number and then computer number as integer. So let's say we want the user to try something like, say, enter a computer number, and that computer number is only known, maybe it's hidden, and then until you are able to, so we assume that the computer number is a secret number, right? So we do that, we assume that you don't know, so try guessing until you get the computer number. So with this repeat keyword here tells you that you have the opportunity to keep entering a number until a certain condition is met. So this is the condition here. So until this condition is met, you keep entering what do you call it, the series of numbers, and we'll be comparing them to the computer number in the program until the number you enter is equal to the computer number. Then that is when we say what the program is. So for us to make this particular program infinite, what we just have to do is just to take off this condition. So what is going to be happening is this: you will keep entering and it will never stop, and you yourself imagine how it will be. So but with this one, it is finite, it is definite. It has a condition which if it is met, it stops there and display whatever. So let's see how the program works. So declare number, the computer number as an integer. So you are to repeat, so please enter a number. So you input a number, then we say set computer number is equal to number plus 1, and you write the number. Now what is going to happen is this: anytime you enter a number, the number is stored in this number variable, and then 1 is added to it, and check is the number greater than the computer number. Okay, let's say that the computer number is 5. Are you getting it? Let's say that the computer number is 5. In this case, let's say that the computer number is 10. Let's just put it that way. The computer number here is 10. So because you don't know whichever the computer number is, let's assume you want to start guessing from 1. Let me assume that from 1, right? Okay, maybe from 0. So the first iteration, you enter a number. You enter the number. So the number you enter will be stored in this variable number here. You store into it, and then 1 will be added to it. Imagine maybe the first time you enter 0, 1 will be added to 0. So 1 plus 0 is equal to 1. So it will check the number here, which is 1. Is it greater than the computer number? No, 1 is not greater than the 10 we are talking about. So it will give you the opportunity to enter again. Maybe the second iteration you enter 5. The 1 will be added to the 5, and check and compare it here, and it will be stored in this number variable, and then compare it. The number here is this. So 5 plus 1 making 6. Is 6 greater than the computer number, which is 10? No. Let's assume in the third iteration you put 9, because you are just guessing, right? You put 9. So what is going to happen is that the 9 will be stored in this particular number variable, and 1 will be added to it, and then it will then check. That will be 10, right? Is 10 greater than computer number, which is 10? No, for now it's equal. So you'll be given the opportunity to enter again. So now the moment you enter another number, which is maybe 20, automatically, the moment you do that, although whether one is added to it or it's not even added, it will just jump out of it, will skip this line of code and quickly come straight forward and write the number to be 20. It means what? The number you've entered, which is what, 20, and is stored in this variable, is what, greater than 10. So until the number is greater than 10, keep doing that. So the 20 is what, greater than 10. So display the number and then you write the end. So that is it. So you keep entering the numbers until the number is what, greater than 10, which we say that it is a computer number. We say so. In here you can decide to set your computer number to any number at all, and then you decide. You can even change this to maybe equal to, if the number is equal to computer number. So in that case, at the moment when we put 10, it means 10 is equal to 10, right? So it will display what, the number 10, and then it will write what, the end, because it's equal to. But here we want the number to be greater than a computer number, and since our computer number is 10, if the user enters a number which is what, 10 is only equal to, so maybe, okay, if the user enters 10, 1 will be added to what, 10 again. So for that matter, what is going to happen is it will be 11, which is what, greater than the computer number, which is 10. So it will display 11, and then it will write the end, and then that will be it. Now let's look at the types of loops, where we have the pretest and then post-test loops. Let's try to understand this very well. So all repetition structures can be divided into two types. The loops we are talking about, I also tell what, repetition, they can be divided into two types. We have the pretest. Now the pretest, we have the pretest and then the post-test loops. These are the two types of loops you're talking about. Now say the test condition occurs before the body of the loop is executed. We'll be seeing an example. So with the pretest loops, the test condition occurs. Pre means what? Before the block of code will be what? Executed. The condition will be tested first. It means after inputting a number or whatever the program is demanding you to input, it will test it before the code under it will be executed. If it turns out to be true, then you are permitted to what? Repeat over again. If it is false, it will just skip that line of code and then quickly go to the code which says that if it is false, that line should be executed. We'll be seeing the example. But with the post test, post means what? After. So you input the number, and then the block of code that is after the input will be executed. Maybe you want to say that. Let me start with the pretest. Let's try to understand this. Maybe I want us to write a program where if you put a number which is even, then display even. You write the number is even. So for the first time when you input a number, if it is a pretest type of loop, the condition comes first. So the moment you input the number, the moment you enter the number, with the pretest loop, the number is tested initially first and check, is the number even? If it is even, before the block of code under which you say if the number is even, something should happen, will happen. If it is not, then it will not. It means it will skip that block of code and go to the next line of code. But with the post-test loops, with that one, when you enter the number, it will display the number before it will just check. If the number is not even, then you'll be given the opportunity to what? Repeat the process again. Unlike pretest loop, which doesn't display the number, it only tests before it displays the number. With the pretest loop, the moment you wanted that if you enter the number and the number is even, it should be displayed. It should be displayed. If it is a pretest loop, the number will not display until the condition is checked. So with the pretest loop, when you input the number, it will not display. The condition will check, is the number what? Even. If it is even, that is when it will display the number. But with the post-test loop, when you enter the number, it will display before it will compare and check the condition. So with the pretest, it will never display until it is checked. With the post-test, it will display before it checks. So that is how it is. So now let's look at the pretest counter control loops. So use a number variable and a condition statement to determine how often the instruction inside the loop has to be executed. Now with this, we have a number we call the counter control loops. With that one, you set a number which keeps counting as the loop as the repetition is going on, as the program is looping through, you set a particular number. If it's up to that limit, up to the limit of that particular number, then maybe something should happen to the program. Maybe the program should end and display something like that. That is what we talk of what? Pretest counter control loops. So it's what? Use a counter variable that is a particular number which says that if you enter this and this happen, increase it by 1 or decrease it by 1 or something like that. We'll be seeing the example as we proceed. So let's check here. Very good. This is a typical example of what? Post test. So in here, this is a flowchart, right? It's a post test. So enter a number. We want the user to enter a number. If the number is even, display even. Are you getting it? If it is odd, then don't display. So yes, if it is even, just display even. So that's what we want. If it is odd, skip. It means the statement is what? False. So skip that and come and display this and say what? The number is what? Is odd. So here we instruct the user to what? Input a number at this stage. Maybe input a number. So with the post test, after inputting the number, it will display the number before it will ask itself, is the number even? If it is yes, maybe you are permitted to what? Enter another even number again. So if it is yes, then go and enter. Maybe you are to input even numbers in series, right? Input even numbers in series. First of all, you input the even number. It will display the number before it will come and check. Is the number here even? If yes, oh my friend, enter another even again. You are given a chance to enter because the first one is correct. So enter another even again. You enter and check. Is it even? If it is yes. So if you enter a number which is not even, it means it is false. So it will come and display this and say the number you've entered is what? It's not even. Rather, it's odd. So basically that is that. So with the post test, after that, after you entering the number, it will display. It means it will execute the loop body. What loop body is it executing? The displaying of the number. It will display the number before it checks the condition. If the number you've entered which is displayed is what? An even, enter again. If it is odd, don't enter anything again. Just come and display here and say the number is odd. So that is that. That is a post test. But let me just use this one again to cite an example of what? The pretest. With the pretest, the moment you enter the number, it will not display the number. It will ask, is the number even? If it is even, display the number and then enter another number again. Have you seen it? So that is the difference here. With the pretest, the moment you just enter the number, this block comes first. This condition comes here and check. Is it even? After inputting it, it won't display it. Is it even? Before it display, it has to check. That is the pretest. If it checks and it's even, enter again. If it is not even, then come and display and tell them it's odd. So that is that. So this is another example of post test loop which is written in pseudocode. So declare number as what? Integer. So here we have to repeat. Anytime you see the repeat keyword, it means you have the opportunity to repeat a task over and over again. So write, enter a number. So this display on the screen. So the user sees this and then it enter a number. So after entering the number, it will display the number here. Have you seen it? Before it will check, is the number equal to 0? If it is equal to 0, maybe end the program or maybe enter another number again, depending upon what, how you maybe program your algorithm to do for you, or depending upon the requirement of your program. So let me go over again. Say what? Declare number as an integer. So whatever number you enter, so it will check. So repeat means what? You have the opportunity to repeat, but there is a condition at stake which checks anytime you input a number. So write, enter a number. This displays on the screen. The user sees this and then you enter a number. So you input a number here. After that, since it is a post test, it will write the number before it will check. Post means after writing the number, check. So good. So after you entering the number, it will write the number and check. Is the number equal to 0? If it's equal to 0, then write end of list. Then that is it. If it's not equal, then enter another number again. Then it will check. Maybe the first time you enter a number which is 1, so it will write this number down 1. Then it will check. Is 1 equal to 0? Is equal to 0? If it is no, enter another number again. You keep entering until the number you enter is equal to what? 0. That is when it will say list ended. It will display this list ended for you. So that is that. So basically, this is a typical example of what? Post test loop example. This is written in pseudocode. Post test, it means after the number is displayed. That is when it is tested. After you inputting the number, it is displayed before it is tested. But if it is pretest, the moment you input the number, this one comes and check, is it equal to 0 before it will display it. So that is the difference there. Let's look at another example of what post-test loop, which is also called the do-while loop. It's a do-while loop is a typical example of what post-test loop. So let's see how that happens. Say do-while loop is just like a while loop, except that the test condition is checked at the end of the loop rather than the start. This means that the content or the statement of the loop are executed at least once. With a while loop is a pretest loop. So let's note the difference here. The do-while loop is a post-test loop, whilst the while loop is a what? It's a very soon we'll be seeing the while loop itself, and then the for loop we'll be seeing them. But now let's deal with the what? The do-while loop, which is a typical example of what the post-test loop. The do-while loop is just like a while loop, except that the test condition is checked at the end. So with the while loop, the test condition is checked at the top before it will display whatever maybe output you want the program to display for you. But with the do-while loop, it will display it before it will come and check the condition at the end. That is the difference here. So the test condition is checked at the end of the loop rather than the start. So with the while loop, it checks at the start, but with the do-while loop, it checks at the end. This means that the content or the statement of the loop are executed at least once. Is executed at least once after you entering the number. Let's say the number you have to enter is an even number. When you enter the even number, it will check at least what? Once before it will come. So let me go over this again. Say do-while loop is just like what? The while loop, except that the test condition is checked at the end of the loop. So with the while loop, it checks at the start, but with the do-while loop, it checks at the end. So this means that the content or the statement of the what loop are executed at least once. So that is the difference here. Now, if the loop is executed once, the test condition is what? Evaluated. So when you enter the number, it will display it first. That is a do-while loop, because it's a what? It's a post-test loop. If the loop is executed once, then the test condition is evaluated. When you enter the number, which is even, it will check and go back and compare. Is the number even? If it is true, then the block of statement is executed again. If it is true, enter another even number. This means that it will keep looping till the result of the test condition turns out to be false. It will be giving you the opportunity to be what? Entering the even numbers until you enter an odd. That is when the test condition turns out to be what? False. And when that happens, then the block of code which says that if you enter a number which is not even, which is odd, display, then that is when it will skip displaying the even number and come and display the block of code which says what? Display odd number. It will display the odd number, telling you that the number you've entered is not what? An even number. If it were to be even number, you'll be given the opportunity to be entering them again, over and over and over again. So you'll be entering them until you enter an odd number. That is when it will not give you the opportunity again, but rather it will skip that opportunity and then come to the block which says that, hey, the number you've entered here is not what? Even, it's rather odd. So that is it. It will display that and then finish. That is that. So do-while loop is also considered as what? Indefinite loop. It's also considered it is considered to be a post-test loop, since the expression is what? Tested at the end of the loop. So is that what? Do-while loop is also considered as what? Indefinite loop. It means what? It's like you keep looping now. It's considered as indefinite loop because you'll be given a chance to be looping. Imagine maybe you don't know the test condition in mind, so it will keep repeating itself. So it makes it like it's indefinite. It doesn't stop until maybe by way of guessing or whatever it is, you are able to what? Get what meets the condition. That is when it will what? Maybe terminate and display whatever output you want it to what? Maybe display. So basically that is that. Now let's see a typical example of do-while loop. So we could write the code as this: declare number as what? Integer. So the number we want the user to enter should be an integer, so we are declaring it as what? Integer. So what? Right, enter a number. Since it's a post test type of loop, after entering the number, after this anytime you see right here, let me just, we've already talked of it, but let me explain it once again. It means this is what will display on the screen for you to see that They say you should enter something, so you input a number. After inputting the number, it will display the number and check until the number is while number is not equal to 0. It's as long as the number you enter is not, this is what you mean by not equal to. As long as the number you enter here is not equal to 0, keep entering the numbers. Keep entering. So that is why they were referring it to as what? Indefinite type of loop. So imagine you don't know, so you are just entering the numbers randomly, 9, 5, 25, maybe by way of doing, your mind didn't even come to 0 at all, maybe 100, 250, whatever. At that moment, it looks like what? Indefinite type of loop, or maybe infinite type of loop. So you keep entering series of numbers. Anytime you enter the number, it display and check. It's not equal to 0, so it will keep asking you to do that until you enter a number which is what? Equal to 0. That is when the test condition here becomes what? False. They display what? List ended. But as long as the numbers you enter is not equal to 0, so while the number is not equal to 0, it means if you enter one, it is true, the one is not equal to 0, so the condition remains true. Anything you enter which is not equal to 0 makes this condition what? To be true. Until you enter a number which is what? 0. That is, say, hey, this is false because 0 is equal to 0, so it will display what? List ended. So this is a typical example of what? Do while loop. So this is how it's written. Declare number as integer. So do. So what do you want the user to do? Displays this, write the number, then the user inputs the number, then you write the number here. Then after that, you display the number for the user to see. If the user enters 5, display 5. Then you check. 5 is not equal to 0. Enter again, so the user keeps entering until the user enters a number which is what? 0. Then it will say, hey, this is equal to 0. It's not. You can't say this, but you can't say 0 is not equal to 0. For that matter, this condition has become false. So you just come and tell the user that, hey, list ended, and that is all. So the program ends there. So let's look at a pretest loop here. This is a typical example of a pretest. So here maybe we have to input an even number again. Good. So with a pretest, the moment you enter it, it will not display. With the post test, it will display before it checks the condition. Take note of that. With the pretest, let's say the user, hey, input a number. So the user does that. The user inputs a number here. Then we check, is the number even? If it is even, oh, tell them to be, maybe the program should prompt the user to be entering even numbers over and over again. So as long as the numbers you keep entering are even, you have to keep entering them and join them again. So this program will be very good program for our students. So you keep entering numbers that are even. So there can be something like a time somewhere. So as they do that, then the time is increasing. Maybe at a point in time where you mistakenly enter an odd number, then you stop there, then we compare your time to that of your colleague. Anytime you enter, maybe there should be a score after that. It will be a very nice game. We'll try writing something like that, and then maybe make it executable for it to run on our machines. Our students should play it at least, for them to also enjoy. Maybe we'll be doing that in Python program. We can all come together, decide on how the program should work. That is how basic softwares are developed. So that is that. We'll be trying something like this. Just realize it. We'll do it. Let's see how it goes. So with the pretest loop, you prompt the user to enter, maybe you want the user to enter an even number, right? So enter the even number. I will check the condition before I display it. If it is even, display even, then you enter another even again. If it is even, as long as the user enters numbers that are even, keep entering. The moment I enter a number which is odd, hey, my friend, this is not even, so don't come here. Skip this block. Come and tell them that what number you've entered here is it's odd. So execute this block and tell them that. So basically that is that. I hope you understand that. Yeah. Keep entering even numbers. The program should prompt the user to what? Enter even numbers. Hey, I've entered 2. Is it even? Yes. Enter. 4. Is it even? Yes. Enter. 6. Is it even? Yes. Enter. 8. Is it even? Yes. Enter. 10. Is it even? Yes. Enter. 11. Is it even? No. This is all. And this one is skipped. This one is executed. So simple as that. While loop. While loop. The while loop is mostly used to repeat a section of code an unknown number of times until a specific condition is met. The problem about while loop is this: the number of iteration is not known. When you want to write a program in which the number of iterations, the number of times a block of code will be executed is not known, we normally use while loop. So that is that. I repeat this again. While loop is used when the code, maybe the number of times you want a particular code to be executed, the iteration or the looping, the repetition, you want it to be repeated is not known, is unknown to you. That is when we use the while loop. So the while loop is repeated as long as the test condition remains true. So as long as the test condition remains true, keep repeating the process. The condition is usually a relational statement which is evaluated to either true or false. Yes. If the condition is true, keep repeating. If it turns out to be false, jump out of the loop and tell them whatever you want to tell them, depending upon the program. The while loop is one type of a pretest loop. So it means after entering whatever you want to enter, it will test it, pretest, it will test it before it displays it, or before whatever you want it to happen to your inputs will happen. It will test it. That is what we term as what? Pretest. While loop is a typical example of what? Pretest. So this is the while. You say the while loop has the syntax. So as long as this condition remains true, keep display the statements, execute the statement, execute the statement, execute the statement. If it turns out to be false, jump all the statement and come and execute the one which says that if it is false, it should be executed. So you do that. So let's check out the flow chart here. Say what? As long as the condition remains true, be executing this one. Hey, even number. Enter even number. I don't know why I'm using even numbers. Enter even. Okay, let's say enter odd numbers. So 1 odd. So I'll repeat again, right? Because it's true. 3 odd, I'll repeat again. 5 odd, I'll repeat again. 7 odd, I'll repeat again. 11 odd, I'll repeat again. 12 even, our friend, is false. Jump out of it and then. That is that. So until the numbers you enter here are odd, which is making this condition true, this particular block will be executed. If it turns out to be false, which means you entered an even number, this one skipped. This one is executed and then that's all. So while loop example in this tree. So this is another typical example of while loop. And that is also known as what the pretest loop. It tested before it displays or whatever. So right, enter a number and then enter 0 to quit. So this program is a simple program where you have to be entering series of numbers. But if you want to quit the program, the moment you enter 0, it quits the program, right? So that is that. So declare number as integer. So the number we want the user to enter is what? Integer. So what? Right. So we display this, enter a number. So we display this for the user to see. Anytime you enter 0, please, it will quit the program. So you are seeing it. Fili Gadochi. Again, you are seeing it. So you say what? Enter a number. So you are to enter series of numbers. So what? Input a number. So this one looks like what? Indefinite. But with this one, we know how we can quit it. That is when we enter 0, we quit the program. So input a number. So when you input a number, it will not write the number. It will test it before it will write it, because it's a what? Pretest. By now, I'm sure you understand the differences between pretest and then post-test types of loops. Sure. I pray you should understand, because it is key to understanding the core concept of what? Loops. Good. So let's proceed. So what? Right. Enter a number. So you keep entering the numbers, but then when you enter a number, it will not display. It will test it. If it tests the number and then it meets this condition, so what? Keep entering the numbers. As long as the number you enter is not equal to 0, any number you enter, it will test it. It's not equal to 0, then it will display it here. Then it will ask you input again, then you input, then it will compare. It's not equal to 0, then it will display. So when you enter 0, then that is when it will quit the program and then write end of list or list ended. So that is that. So you keep entering the numbers which are non-zero numbers. 1, 5, 7, 8. So when you input a number, it will check, oh, it's not equal to 0, so it will display it here. Then it will ask you input again, then you input, it will check, it's not equal to 0. Input again, you input 3, it's not equal to 0. Input, then it will write. Input again, you input 100, it's not equal to 0, then it will write until you input a number which is what? 0. And that is when it will quit and terminate the program for you. So basically, that is that pretest. So this is while loop example 2. Say write an algorithm to display numbers from what? 1 to 110. This particular program, let me just give you one of the useful tips of what loops, how loops can summarize our programs. If here we just want to write a program to display these numbers for us. If you want to write the program in real way, in real sense, what is going to be happening is this. Like in Python, we use print to display an output for a user to see something, right? Good. So what we've been doing is this. We'll write print 1, print 2, print 3, print 4, print 5, print 6. So we'll write prints up to print 110. So you can see that at the end of the program, we should have what? 110 lines of code, because each line should print 1, print 2, print 3, and that order. But look at how 110 lines of code have been what? Summarized. That is the power of what? Loops. So we have to declare the number as an integer. So number is equal to 0. So while number is less than what? 110, do what? Display the number. After displaying the number, add 1 to the number the user that you display. So in the first iteration, number is equal to 1, it will display 1. Then after that, 1 is stored in the variable number, and then it's equal to what? Number again. So 1 plus 1. So it will, in the second iteration, it will display 2. 2 is stored in this. So 2 plus what? 1, making 3, second iteration. So when you run this program, it will just run once and display the numbers from what? 1 to 110 flat, and then that is it. Instead of you writing print 1, print 2, print 3, print 4, print 5, print 6, and print 7 up to print 110, you have just summarized it in a very simple manner here. Have you seen it? Very simple and then outstanding. So basically, that is how that is how useful loops can be for us. Very, very useful. Very, very, very useful. So we'll see how we can use them in our games and all that when we begin writing our real programs in Python. So let's go ahead and check or write again. So an algorithm to display numbers from what? 1 to 110. Could have written it line by line up to 110 lines of code, but then loop has done that for us. So declare the number as an integer. So number 1, number is equal to 1. The first number we want the program to display is 1. So as long as the number you enter is less than 1, so keep adding 1 to what? The series of numbers and be displaying them. So when you enter 1, it will display 1 first. Then initially when you write the program, it displays 1, and then the 1 is stored in a variable number. So 1 is added to it, and then making it 2. It displays 2. So it will check 2 is less than what? 210. It will add this and then display 3 up to that. It will continue exactly 110. It will stop there because it said it shouldn't be greater. It should what? Be less than. But if it is 111, it won't even get 111. Then when it gets 110, it will display numbers from what? 1 to 100. So let's just see how the output will look like. So in the first iteration, it displays 1. In the second iteration, it will add 1 to what? While making it to display 2. Third iteration, it will add 1 to what? To making it 3, displays 3. In the fourth iteration, in that order, up to the 110. So with the program here, when you run it once, the moment you just hit the enter path, 1 to 110, you are done. It's not like writing 1, display 1, print 1, print 2. No, that is boring, right? So that is that. Let's look at pretest loops where we have the counter control loops. So there are loops that execute a certain number of times without any user inputs. This kind of loop is constructed with a special type of what? Pretest loop known as counter control. Basically, this type of loops, we set some counter variables, and then before we start entering whatever we want to enter, we know the number of times we have to do that. Maybe if it is a game, you know that you have 3 lives. If the lives are exhausted, then the game is over. So that is that. Say there are loops that execute a certain number of times without user input. So basically that is that. Say this kind of loop is constructed with a special type of what? Pretest loop known as what? Counter control. A counter control loop is a loop that is what? Executed a fixed number of times. The number of times that the loop or the block of code should be executed is there. It is set. We all know it. So where that number is known prior to entering the loop for the first time, before you even begin running your program, you know the number of times the block of code should be executed. You know it. So that is with the introduction of the counter control loop, with the introduction of a counter control variable, we know that the counter control variable tells us the number of times the loop should be executed, or the program should repeat itself. So that is that. Let's look at it. So a counter control loop contains a variable. The counter, that variable is known as the counter. That keeps track of the number of passes through the loop, the number of iteration. So like I'm saying, in the game programs where we have the number of lives, if we set the number of lives to be 5, the 5 there becomes what our the counter or the counter variable. So we are with this having 5 in mind. We know that we have to play this game having 5 chances. We can't play more than 5 number of times. We get to 5, then game is over, is whatever. So we know the number of times. So when the counter reaches a preset number, the loop is exited. When you play up to 5, that number of lives you have given to your program, and the program stops there, and then it exits, tells you the game is over. Those of you who have joined our Scratch program, and you know very well I'm talking about, where we set the number of lives. When we get to that number of lives, the game is over, it displays that. So basically that is that. In order for the computer to execute the loop a certain number of times, it must keep track of how many times it goes through the loop. So before the computer will know that you have to set a counter variable. So it stores this number in the counter. So when you set a counter is equal to 5, 5 is stored in the counter. So anytime it loops, it checks. So that is 1. It loops again, it checks 2, and be comparing it. Is 2 greater than 5? No. So you have to do again. So it will repeat. 3 greater than 5? No. When you get to 5, it's equal to 5, it's not greater. But you get to 6. So the moment it gets to 5, it stops there, because you're not supposed to play more than that. It's set to what? 5. So basically that is that. So using a counter, so to keep track of how many times a loop has been executed using a counter, you must define initialize and either increments to count up or decrement to count down. I talk of this. If you want to increment it, you set it to 0, you keep incrementing it up to maybe the number of times you want the program to run. If you want to decrement it, you can set it to 5, then you keep decreasing it. In any of the iterations, it decreases minus. If it's increment, any of the iterations, it increases. That is by plus. So that is that. So you define a counter. Define a counter means the number of times you want the program to get executed or to run. Then the counter variable is always an integer. It's a number, right? It's a number that we can either increase or decrease. We can add or reduce or subtract. So after that, you initialize it, you start it. So you set the counter at the beginning value. So here at the beginning value, you set it at the beginning of the program before it starts. So prior to your starting, you know the number of times you are going to run the program. So set count is equal to what? Maybe 0. Set count is equal to what? Maybe 1 or 5, depending upon the program's requirement. It depends upon how you want your program to be. Let's say you want to write a simple guessing game. You may decide to give the user the number of chances the user should guess. If it is 5, then the moment the user enters 1 minus 1, remaining 4. If the user didn't get it, there is a program at the end which will just open up everything we are talking about here for us to see plainly. It's a simple game program, guessing game. When we get there, so depending upon the number of times you want the user to guess. This can also be a very good program when we want to write a program where maybe the user, our students can be testing their skill, maybe objective test questions. Maybe we have questions that the student will answer in the program. Maybe in the first testing, maybe after entering the first number, if it meets a certain condition, then you are given a chance to enter again until the condition turns out to be false. You don't have the opportunity to do that again. This is used in our games we play every day. So I pray you understand what I'm talking about. So let's look at example here. Say declare count as an integer. So declare activity. So this is a very simple program which says that enter 3 things you like doing in your free time. So you enter the things you like doing in your free time. Then we are trying to concatenate. You know what I mean by concatenation? In the output of the program, we would like to concatenate you enjoy plus activity. So for instance, let's say I input the activities I like doing is 1, eating, 2, sleeping, 3, programming. So in the output of the program, it will say you enjoy eating, sleeping, and programming. So that will be the output, because we are concatenating the activity. So whatever activity I enter is stored in this activity variable. Then we concatenate it to what you enjoy string, and it displays what I just read. So basically that is that. So right, enter 3 things you like doing in your free time. So with this, while counter is less than 4, we set count to be 1. In each of the iteration, it will be incrementing it. So this is the incrementing here we are talking about. So we set it as 1, and then we initialize it here. Have you seen it? It's initialized. So the moment you run the program, so it will give you the chance. Enter 3 things you like doing in your free time. So I'll enter. I like reading, eating, sleeping. So it will input it and it will display you enjoy reading, eating and sleeping. Then after that it will check this is the first time. So it will do what? It will store it in this counter variable. So at this moment I will be given a chance to do that again. The second time it will add 1 to the previous one to make it 2. The third time I will do that again. Means I can enter as many as I can, but then when I enter the third time it becomes 3, right? So it will compare. The count is what? Still less than 4. So I have the opportunity to what? Enter again. So the moment I enter, which is equal to 4, so that is when the program will end. It shouldn't be what? Greater than 4. So it means as long as the count variable here is less than what? 4. Initially you can see that when it's initialized it's 1. So it's automatically less than 4. So you are given the opportunity to what? Enter your activities again. So when you enter again, making it the second time, which is still less than 4, enter activity again. When you enter the third time plus the previous 2, making it what? 3, which is less than 4, enter activity again. If you enter at that moment is equal to what? 4. So when it is equal to 4, that is when the program what? Stops there. It should be less than 4. So it means that when you get to 3 is less than 4. It shouldn't even be equal to 4. It's less than 4. The moment is less than 4, that is when you have the opportunity to. 3 is less than 4, right? Very good. So after you enter your activities for the third time and it becomes 3 here, it's still less than 4. So you enter the fourth time, which is equal to 4. So at that moment the program should stop there and then tell you that it will display all your output, or maybe activities you input with this, and then you see everything, and then the program ends there. Because why? The counts, the program says that it shouldn't be more than what? 4 times. It should be less than 4. It shouldn't be greater than 4. So as long as the count is less than 4, keep entering. But the moment is what? More than 4, stop there. You can't keep entering your activities more than 4 times. You have only after 3 times. So you can see that this particular looping concept here is used in what? Our login systems, where you have the number of times you're going to log in. Or maybe just look at the typical example. Our what do you call it? Please, on our Android phones, I mean the locking system on our Android phones, the pattern. Thank you very much. Imagine this word just missing. The pattern on our Android phones. Imagine, the number of times you have to what? You do it. So you can see how useful loops are. They are used in this particular concept, where you have the number of times you have to what? Draw your pattern to open your phone so that you can do whatever you want. And this loop is used there to stop any malicious user from entering into your phone. Because who is a malicious user? Someone who the phone does not belong to. He is the person who tries to guess as many as they can. So loop is used to check the number of times you have to guess. So as the rightful owner, you don't even have to enter it twice. It should be once, and then you do that. So if a malicious user comes for your phone with the loop and the counter, and then the counter variable in the loop there is checking that, hey, you have only 3 times. So you see that when you enter the 2 times, then they tell you have only 1 attempt. So that is what the counter variable does. It is set to be 3 times. So you can't enter more than 3. If it gets there, it will lock the phone. So that is how it has been programmed. So anytime you are running a particular program and there is a loop in there and there is a counter variable running in there, you understand that at this point there's a counter variable is working there. So that is how we try to understand how other programs are and softwares are developed. We try to, as we use them, we try to understand. Now from now onwards, anytime you are using a particular program, try to understand how is it built, how is this happening, how is this, and all that. So you try to understand the concept of the program, how the program is built, what is making this possible to do this. So you try to understand all that. So that is what makes you a very powerful program. So you can see that from now onwards, you can even tell me examples. So your assignment is this: in real life activities, where from use of our phones, our televisions, PCs, and the games we use, can you give me examples where loops or the concept of loop is used? I have just given you one, and that is what the pattern on our phones. Like I said, you have the number of times you have to draw your pattern to unlock your phone. The counter variable there is checking the number of times. If the counter variable is set to be 3, and maybe if the limit is set to be 3, it's incrementing. So you draw the first pattern 1, draw the second pattern, you start making it 2, you draw the third pattern, that is the end. You draw the fourth one, you lock the phone. So the loop concept is working over there. I pray you understand what I'm talking about. So that is that. So in here, once again, declare activity as string, set count is equal to 1, set activity as empty string. We are setting activity as empty string because initially you haven't entered anything. So this is where we prompt you to enter something. So you enter it, then we check the condition. So even before you even do that, maybe someone has already entered the activities twice, then you come for the program. Maybe the third time you come for the program and enter only once, and you tell you it's out of. You are out of what? You can't enter activity again. It means you've exceeded the limit, because the limit says that it should be what? Less than 4. 4 is not less than 4. 4 is rather equal to 4. So for that matter, the condition here turns out to be what? False. 4 is not less than 4. It's equal to 4. So false. If it is false, to jump out of the loop and tell you it's over. So this is the flowchart to the pseudocode you saw there. So declare count as integer, declare activity as string, set count equal to 1, activity as empty string. So you have to write enter 3 things you like doing. So you enter that, and then we check the count variable. So whatever you enter here, then we do what? We input. So input activity. So after you input your activity, if the count here, when you enter whatever you want to enter here, if the count here is less than 4, then you have the chance to what? It will display this, and then you have the chance to enter again. You keep entering until the count here is what? 4, which is equal to 4. That is when the condition here is what? False. So as long as the count here is less than 4, the condition remains true. And as long as the condition remains true, you have the chance to keep entering the activity over and over again until the condition here is false. That is when 4 is equal to 4 here. That is what makes this condition to be false. And if it is false, you jump out of the loop and then you exit the program. So that is that. So example, this is an example of a decrement counter. And this particular counter is decrementing. So we are declaring, it's like reducing based on some conditions, right? So that's it. Declare count as integer. We set the count to be what? 100. So here we are going to be decreasing here, decreasing until we get to 0. So write count in. So whatever you write, counting. So whatever you count, maybe you write maybe 1. So 1 will be what? Subtracted from what? The count variable, which is what? 1. So while count is what? Greater than 0, keep writing. So write count, maybe write 1. Then it will do what? To check 1 is what? Greater than 0. So it will subtract from this. So you keep doing that. As you write or as you count, it will keep what? Subtracting. And then from the first subtraction, this remains 99. So 99 is still greater than 0. Then 98 is still greater than 0. Then 97 greater than 0. Then 96 greater than 0 until it gets to what? 0, where we say 0 is equal to 0. So that is when it will end there. So as long as this number here, the count here, which is 100, is greater than 0, you have the chance to do what? Counting, or entering your count, or writing your count, or whatever you want to do. So as you do that, it is reducing by 1. Then you reduce by 1. Whatever you do, reduce by 1. If it's reducing by 1, what is going to be happening is checking 99. It's still greater than 0. So go over again. So until we get maybe 0, which is equal to 0. That is when it will end the program, because we say what? It shouldn't be what? As long as the condition remains same, as long as the count is greater than what? So even when we get to 1 is still greater than 0. So until the count remains what? Or gets to 0, that is when we say what? 0 is equal to 0. So at that moment, you write count plus seconds, the number of counts plus the number of seconds. So we try to concatenate this count by maybe say 100 seconds or maybe 0 seconds. So 99 seconds counting, then 1, then it subtract 99 seconds, 98 seconds. So we are concatenating. So anytime, let me just explain this thing very well so that you understand, right? We set count to be equal to 100. So count is inside this count variable. So when we count 1 here, remaining what? 99. So it will check 99 is greater than what? 0, right? So it will write 99 plus, so it will write 99 seconds because we are concatenating 99 plus. So 90, you know the output of this 99 seconds, this is concatenation. Then it will reduce again 98 seconds, 97 seconds until it gets to what? 0, which is equal to what? 0. That is when it will end the program there. So it's end the program and then write what? Blast off. That is means the program has come to what? An end. So that is, this will display at the end of the program. That is when 0 is equal to 0. So that is that. Now let's come to for loop. The for loop provides a shortened method to initialize the counter. Tell the computer how much to increase or decrease the counter for each pass or iteration or repetition through the loop, and to tell the computer when to stop. So with the unlike while loop, which we don't know the number of times the block of code will be iterated or repeated or be executed, the for loop we know. That is when it says that it is best used to repeat a specific block of code for a specific number of times. We know the number of times. Say, for loops use a counter variable and a condition statement to determine how often the instruction inside the loop has to be executed. With the counter variable and the conditions, we know the number of times a block should be executed because we know the counter variable tells us this. So with the for loop, it is used when we know the number of times a block of code should be executed. So for loop statement or the syntax, this is it. Say for the counter is equal to what? The initial value, then the test condition, then the counter, that is the update or body of the loop. Now end for. Now the for loop has to be initialized before the loop can be executed. Before you start, you have to initialize what? The counter variable before the loop will be executed. Now the test condition tests whether the statement is true or false. If the statement in the body is executed, if the statement in the body are executed, I'm coming, please. So the test condition tests whether the statement is true or false. If true, as long as the statement remains true, the statement in that body is executed. As long as it remains true, it's executed. But as it's still executing, it's checking the counter variable in question. Else, if it is false, the loop is what? Terminated, and then execution continues from the next statement. The examples will help us here. Very good. Example 1. Let's say 4. The count is equal to 1. Say count less than what do you call it? 4. So we say count plus plus. Then we write count. So n4. Now what is going to happen here is this. We set the first count, the counter variable to be equal to what? 1. So in the first iteration, it will display what? It will write what? Count, which is 1. Then after that, 1 will be added to what? We set it, the count should be what? Either less than or equal to 4. So in the first iteration, it will write what? 1 and check. 1 is less than or equal to 4. It is true. So after that, 1 will be added to 1 again. That is what we see plus plus here. It means we have to add 1 to in each of the iteration. In each of the repetition, after writing the count, say write count. When we said count is equal to 1, it means in our count variable, we have 1. Write count means write what is in the count, which is 1. So you write 1. After that, then we check. Is count less than or equal to 4? Yes, 1 is less than or equal to 4. So we add 1 to what? The 1, making it 2. Then we write what? 2. Then we check. 2 is now stored in the count variable. Now is 2 less than or equal to 4? Yes, if it is true. Then we add 1 again. 3. Is 3 less than or equal to 4? Yes. Then we add 1 again to 3. 4. 4 is less than or equal to 4? Yes. So it will end there, and then it will display 1, 2, 3, 4. Let's see the output of the program. Very good. So they say what? For count is equal to 1. So let's see. With the count at the initial stage, when you say count is equal to 1, the count, the 1 is stored in this variable count. When we say write count, we see this 1. So the first iteration, 1 is written. So it's compared. 1 is less than or equal to 4, right? Yes. So the count plus plus says what? Add 1 to what? The count. So you add 1 to 1, making it 2. So it will display 2 now. Then it will check. 2 is less than or equal to 4. Yes. It will add 1 to what? 2, making it 3. Then it will check. 3 is less than or equal to 4. Yes. To add 1, making it 4. 4 is less than or equal to 4. Yes. So it will end there. So the loop is executed with the count equal to 1 on the first pass. So at the first pass, it will write the count. Then the second one, 2. Then 3. Then finally 4. So the output of the program will display 1, 2, 3, 4 in that order. So basically that is how the for loop works. So it's the same thing that they are just explaining to us here. Say for count is equal to what? 1, count less than or equal to 4, count plus plus. So the loop is executed with the count equal to 1 on the first pass, then 2, then 3, and finally 4. So the output of the program segment consists of what? The numbers 1, 2. In the first iteration, write 1, it will write 1. Then it will check 1 is less than or equal to, so 1 remain there. But then it will add 1 to what the previous one and then write 2. Then it will check 2 is less than or equal to what. So anytime it's written, it's stored in a counter variable before it will compare it to this condition here. Is 2 less than or equal to 4? Yes. If it is yes, then it will add 1 to 2, making it 3. Is it less than or equal to 4? Yes. It will add until it's equal to what? Until it gets to what? 4. That is when it will display all this 1, 2, 3, 4, and then end the program. End 4. So that is how it is. So example. So what? For count is equal to 0. So this is the decrement counter type, right? Here we are going to be we are going to be incrementing it rather. We are going to be increasing it. Yeah, we are going to be, because we have the plus here. The counter variable says you should be increasing it by 5. Initially, we set the count to be what? 0. So in the first iteration, it writes 0. It will compare 0 is less than or equal to 15. It is true. So add 5 to 0. So 5 plus 0 is what? 5. In the second iteration, it writes 5. Yeah, 5 is less than or equal to 15, so it displays 5. In the third iteration, 5 is what? Added to 5 again, making 10. So in the third iteration, it writes 10. It will compare. 10 is what? So anytime it's written or is added, it stores in the counter variable before it can compare. So take note of that. So if it is the third time, then 5 will be added. Let me start over again so that you understand me better. So for initially, we set the count to be what? Equal to 0. Then we say what? The count should be less than or equal to 15. So this is our test condition. So this is our counter variable. So we write count. So write first iteration. It will write 0. Then after writing the 0, then it will iterate. It will loop, and then it will add 5 to 0. Then it will display what? 5. Then before it display, it will check 5 is less than or equal to 15. Yes. Then it checks. The third iteration, 5 will be added to 5 again to make it 10. Then it will check 5 is less than or equal to 15. Yes. So it displays 10. In the third iteration, 5 will be added to 10, making it 15. 15 is less than or equal to 15. Yes. So it will end there because we don't exceed 15. The limit is up to 15. So we end there, and then we display 0, 5, 10, 15, and that ends the program, and then end 4. That is that. So this, yeah, that is what is the same thing as what we saw there. So say for the count is equal to 0, count is less than or equal to 15, count plus. So in the first iteration, this displays what? 0. Second iteration, 0, 5 is added to 0, it displays 5. Third iteration, but before it displays, it compares here. So 5 is still less than or equal to 15. Then 5 is added to 5, making it 10. 10 is less than or equal to 15. 5 is still added to 10, making it 15. 15 is less than or equal to 15. So it stops there, it doesn't exceed 15. So it ends there and displays 0, 5, 10, 15, and that ends the program. So in this program segment, the counter is the variable named count, and it's initialized to what? The constant 0. So that is what we are talking about. This is the counter variable. It's initially set to be what? 0. But as it's looping, it's incrementing by what? 5, 5, 5 in that order. The same story here. The same story. So, right, count is equal to what? So in this program segment, the counter is a variable named count, and it's initialized to be what? Constant 0. The increment is 5. So here, this means what? Increase by 5. The counter plus 5 tells the computer to what? Add 5 to the value of the count. So in each of the iteration, you add 5 to it until it gets to what? Less than or equal to 15. So it will display 0, 5, 10, 15, and then it jumps out of the loop and then end the program. So the same story here. So let's forget about this. So yes, I like this one. This is the decrement style. So for count is equal to 15. So initially we set the counter to be what? Variable to be what? 15. So count is the 15 is stored in this variable count, right? Good. So we say what? Count is greater than or equal to what? 0. So initially write count. It will write 15. So we can say 15 is greater or equal to 0. Sure, it's true. So it will decrease it. So in the first count, it will write 15. After that, to subtract 15, then iterate again and then write 10. Then it will compare 10 greater or equal to 0. Yes, it's true. Then it will iterate again and to subtract 5, remaining 5. 5 is greater or equal to 0. So the third time again, right, it will iterate and then subtract 5 from 5 again, so it will become what, 0. That is when we say what, it will display 15, 10, 5 and 0. So all these numbers from 15, 5, 10, 0 is greater or equal to 0. It means that the number here which is in the count is greater or equal to 0. So 15 is greater than 0, 10 is greater than 0, 5 is greater than 0, but 0 is equal to 0. So 0 is inclusive because it's either greater or equal to 0. So I pray you understand what I'm talking about here. So initially we said it will be 15, so it will iterate. The first iteration, it will compare 15, so it displays 15, right count. It means write 15, write 15. Then it will iterate, subtract 5 from 15, then it displays 10. Subtract 5 from 10, displays 5. Subtract 5 from 5, displays 0. So 15, 10, 5, 0 displays that in the program. Same story here. Same story here. The same story here. So for count is equal to 15. The same story, please. We shouldn't just waste time to prolong the video again. So but let me go over again for the benefit of the doubt. For count is equal to 15, count greater or equal to 0. So initially 15 is equal to what? Greater or equal to 0. So the first iteration it tried 15. In the second iteration, subtract 5 from 15. So it is so count is initialized to what? Constant 15. The decrement is 5. So in each of the iteration, we decrement it by what? 5. That is minus 5. This minus 5 tells the computer to subtract 5 from the value of the count for each of the iteration through the loop. So in each of the iteration, 5 is subtracted until we get to 0, which is equal to 0. So the numbers we will have that will be displayed with 15, 10, 5, 0. So which are all greater or equal to what? 0. So basically that is that. The same story here. For count is equal to 15 and then count is initial. So that is that, please. I don't know why these things are repeating. Now an algorithm to display numbers from 1 to 110. So basically it's like we saw this earlier using a while loop. So we have it again using the for loop. Like I said, it's very useful for us. It is very good for us to know the importance of loops. You understand? Very good. Basically that's what I'm talking about. So an algorithm to display numbers from 1 to 10, from 1 to 110. We could have written, if it is in Python, print 1, print 2, print 3, print 4, up to print 110. That is too much for us, right? So with a for loop, we just summarize it here. So we declare the number as an integer. Number is equal to 1. For number from 1 to 110, do what? Display the number. So in the first iteration, it will display 1. Say okay, then it will come back and check. This should display 1 to 110. Okay, then 2 again, then it will come and check. Oh, 3. So it will display from what? 1 to 110. The moment it gets there, then it ends the loop. So that is that. After displaying 1, next 2, next 3, next 4, up to what? 110. So let's see the output. So example 5, the output of the program says what? This in the first iteration it displays 1, the second iteration next displays 2, third iteration next display up to what? Number 110. So very simple, very simple. That's that. So we try to end our program with a very simple game here. That is a guessing game. So we try to use all our if statement and then the while loop and then the counter variable and all that. So let's try to digest it to our level of understanding. Let's dive right into it. So now this is a simple guessing game where we have to guess a secret word. The secret word is unknown, but we set it in the program, which is what? Leo, so that we can compare to what the user will enter. So as usual, since it's an algorithm, we start right. Start. Declare secret word as a string, because secret word we want it to be a string combination of characters. So we are declaring guess counts, guess counts, and then guess limit as all integers. Now we are setting secret word is equal to Leo. That is the secret word we want the user to enter. So the guess initially is set to be an empty string because initially the user hasn't entered any guess yet. The guess limit here is what? 3. It means you have only 3 times to enter your guess. If it is up to 3, then you are done. So here we say write guess. So this will display. So you enter your guess, you input your guess here. So when you enter your guess, let's say the first you try to enter the word to be come. COME. So we check, as long as your guess is not equal to secret word, as long as what you enter here, which is scam, is not equal to secret word, and your guess limit is less than 3, and the guess limit is what? Less than 3. That is what? Maybe 1 and 2, which is less than 3. Then guess again. So at the first guess, when you guess, before you be given the opportunity to guess again, it will check, is your secret word equal to your guess is equal to secret word. So while your guess is not equal to secret word, so first, if it's not equal to secret word, that's the first condition. It will check that. Second condition, what is your guess limit? The first one, right, 1, so it's still less than 3. My friend, guess again. So it will give you the opportunity to guess. But before it does that, it will record 1. If you guess again, you didn't get, it will add 1 to it, making it 2. If you guess again, you didn't get, making it 3. And then you say what? If guess is not equal to secret word and guess count is greater than 3, it means if it is more than 3, then display you are out of guess, game over. It means that you are not able to get a secret word and the guess count, which we said to be 3, is more than 3, is more than the guess limit. So for that matter, my friend, game is over. But then aside anything means else, aside this, and if this condition remains what? True, guess again. But the moment the condition turns out to be false, means you are able to what? Guess the word. It means hooray, display what? I mean, that is when the else come in. If this and that, display this. Else, display that you have. I'm sure you've understood what I'm talking about here when we did this in the if statement and then else if statement and all that. So here we are combining everything in our game, simple game here. A minute, please. Let me get stuck on something here. Thank you. Just a water break, sorry. So let me go over again. So we are starting the program. Declare our variable secret word, which is equal to as a string. Then we are going to be writing the same program in the Python. Maybe you understand it better there, but before you understand it there, you should understand it here as well. We declare the guess counts, guess limit, all as integers because they are all numbers. And our secret word we want the user to guess is what? Leo. And then the guess initially is set to be what? Empty string. We call this an empty string. But initially the user hasn't entered any guess yet. The guess limit is 3. The user should, by the third time, should be able to guess, else game over. Here we are prompting the user to enter the guess, so you input the guess. So after you inputting, we try to check the condition. As long as your secret word is not equal to what? The guess. As long as the guess is not equal to this, your guess you enter is not equal to secret word, and then the guess limit is less than 3. Enter guess again. So you keep entering. When you enter the first time, it will add +1 to it, making it what? 1. Second time, 2. Third time, 3. So from that time, if you're unable to guess it, then it means it will display what? It means what? If guess is not equal to secret word and then guess count is what? Greater than 3. It means you have exceeded the guess limit, which is greater than 3. Then display you are out of guess, game over. Else means aside, if this condition is false, then display hooray, you have won the program. How will this condition be false? It will be false if it will be false because your secret word is what? It will be false because it's either you get a secret word and you are still in the race to guess, which at that moment your guess count is less than 3. So either you get a secret word which is Leo, and for that matter it will display hooray, you have won. And then what? At that moment, by you getting the secret word means what? You are still in the race to guess, and at that moment the guess count is less than 3. That is why you are able to guess again. So that is what will make this condition false. And if it is false, it means you have won and then game over. So basically, this is how loops are useful in our programs. So I pray you understand the concept of the various types of loops, and then the concept of the pretest loop, the post-test, the do while, the while loop, and then the for loop. So you watch the video over and over again. If possible, you read the PDF document. If there is any question, you can ask for clarification. Thank you very much for watching. I'd like to end this program here. or this tutorial here. In our final tutorial, this is the 6th lesson. In the 7th lesson, we're going to deal with functions. So we'll meet again in lesson 7, which will wrap up the first session of our training on the basic programming techniques. I say thank you very much for watching, and then bye for now.